presentation will be about continuous deployment of data pipelines in the context of the BigDataFlow project. But we try to derive from it some stuff that can be applied to, in fact, any project or platform that you would want to have it deployed continuously. So BigDataFlow is a platform, and users love platforms. As a user, well, I don't need to bootstrap a project. I don't need to care about the project health so much. I don't need to do release. I just need to commit my changes, and 2 hours later, it's in production. And so the agenda for this presentation will be how in BigDataFlow we made breaking things hard, and we'll talk mainly about static analysis there, and you can see that we can go a long way with static analysis. And the second part will be about how we made testing easy for user and trustworthy, because if you can test easily but you don't trust your test, you won't feel comfortable to deploy to production your changes right away. So static analysis. A bit of definition. In computer program, in computer science, static program analysis, or static analysis for short, is the analysis of computer programs performed without executing them, in contrast with dynamic program analysis, which is performed on program during their execution. In this definition, it's written nowhere that it has to be a programming language or any advanced way to describe your program. And so, in fact, static analysis is already done in many places at Criteo. And the program definition can be something simple like a JSON file, a proto object, and the reverse vault loop project is a good example of a place where a QA bot does a lot of static analysis to validate your group is respect Criteo constraints, and when you change it, you won't break like backward compatibility or this kind of stuff. And so, in the context of BigDataFlow in particular, because we built a SQL dialect for this platform for many reasons that I won't go into for this presentation, but because we have this expensive investment, it allowed us to leverage static analysis a lot. So quick, I don't know if everybody on the Zoom knows about, so I will do a quick recap of what is the BigDataFlow SQL language. Starting from the bottom, you see a select statement. Select from where? This, I guess you know. You run the query, you get an output. If you go one line up, you see this insert partition DevXDays. So what this means is just the output of this query, I want to save it somewhere. Then you go up again, and you have these partition enumerators. So with those, we create a list of scopes, and for each of those scopes, we will run the insert select from where statement. So if you add all of this, you don't have a single query that produce output that goes to nowhere. You have a query that produce output that goes somewhere, and you have a list of them. And in fact, this list of queries define your data set. And the top line is just the name of the data set. So to support this SQL language, we have a bunch of code. that's so let's start with the BigDataFlow SQL string. We first have a lexer that chop it into a sequence of tokens. This sequence of tokens, we have a parser that produces a concrete syntax tree. So this is just a tree representation of the SQL string. We are able to format it back to a SQL string, but with a standard formatting so that it's nice to read. We are able to analyze this concrete syntax tree to have an abstract syntax tree, and this is the part that will be explained a little after. This abstract syntax tree is then the support for, well, evaluation. So we are able to evaluate some part of this abstract syntax tree to have actual SQL values, to pretty print it, it's always useful, and to build Hive or Spark SQL queries from it. So this whole thing, well, the first line, the main line is something that is common to all programming language. They all have something that look like this underneath. There can be some more steps for something that runs on the JVM, for example, but in the end, it's something pretty common. If you study programming language, you're not lost. But let me just quickly talk about the analyzer in the context of our SQL language. So starting from a concrete syntax tree, so I put the SQL statement, I spared you the tree version of it. Select name from BI core fancy dim, where ID equal ABC. So what the analyzer will do is it will walk through this query, knowing the available catalog of data. It will produce, by walking through it, the AST that is printed on your screen. So you can see that the name has been identified as a reference to the fancydim table dot name colon. So it's not just a string called name. It's a concept that is understood. And there is also this ID that has been understood as the fancydim dot ID colon. And because this analyzer produced a result and not some errors, it means it also did a bunch of checks, like, for example, this equal expression where ID equal ABC. It said that it was a valid one because ID is in a type that can be compared with a string. So this is analyzer, and this analysis is not done on a single file. It's done on all the SQL files we have in the BigDataFlow repository. So here, for example, I have a change made on the metrology application total SQL file where I just rename a column because I wanted to add something to the name. And if I run BDF check, that Silva will talk to you a bit more after, well, I will have many errors, but one of them will be that the BI metrology core data resource daily dataset is broken because in this file, I have a reference at line 37 to a vCore allocated column that is not known anymore. So here again, well, you probably know programming languages. This is not so surprising. It's not, SQL is just another programming language. Something we can do more, which is a bit more specific to Criteo, is the test we do on the integrations. In BigDataFlow, you can define export of data from Hive to other places. There is many. And one of them is Vertica. So down there, you have this Vertica export that says, okay, I want to export this Hive table to the Vertica multi-tenant cluster on AM6, and there is a bunch of parameters for the export. So with static analysis, we are able to look at this, look at the definition of the Vertica table, which is already in Git somewhere. And with the different parameters given to the Vertica export, we can detect, well, I have a column, for example, zone ID here, which is not present in the Hive column while it is in the Vertica table. So there is probably something wrong there. There will be an empty column on Vertica side. Or we can also check that, okay, I have this zone ID column on the two side, but it's weird because it's an int on Hive side, but it's a varchar on Vertica side. Are you sure this is right? And so, yeah, it's the opportunity to do plenty of tests that are specific to Criteo. And lastly, because with continuous deployment, code review becomes the last step before production, well, we also have tests in QA-Bot where we identify changes. So the actual SQL is fine, everything is fine, but the change from before to after can be problematic. Here, I add two request status to a query, and QA-Bot will tell me, well, are you sure you want to do this? I have an unsafe number of partition modification because this change creates the addition of 3,000 new partitions of data. Therefore, when deployed, it will trigger a massive amount of new computations on the Hadoop cluster. So the committer can add something in his commit message to say, yeah, I'm fine, I want to do this. Or he can think, oh, maybe that's not exactly what I wanted. And in fact, this happens a lot. When you create a new data set, you often set 1 year retention, for example. And when seeing this method, you think, oh, yeah, maybe I don't want to trigger the retro computation of all the data for 1 year ago. And I would just add a start date to 2 days ago so that my data set will have a 1 year retention, but it will start computing only data right now. So you've seen that we can do, and we do a lot of stuff with static analysis in BigDataFlow. However, static analysis has its limits. We leverage Hive and Spark query engines. And similarly, we don't really know the data that they will work on at static analysis time. So if there is scalability issue, data skews, and so on, there is no way to tell. We have implemented a bunch of static checks, but we haven't done everything that can be done because it's expensive to write them. So, for example, we haven't tested if the users have the proper credentials and so on to connect to all the various systems, SFTP, SQL servers, and so on. The implementation I showed you about the Vertica checks, we haven't done it yet for the SQL server, for example, or MariaDB. And lastly, in BigDataFlow, you have the option to execute arbitrary code with run Python, run jars, and there is others. And well, obviously, we can't analyze something that we don't really know about. So it's arbitrary code. There is nothing we can do there. So to cover all of those, where static analysis can do more, we leverage testing. And Well, for users to test before merging, we want the test to be very easy to launch. You see that. And also, super important, the test, we want them to be trustworthy. Because if you test something, but you don't trust that the behavior in production will be the same, your tests are not really valuable. And to talk about this part, I will leave the floor to Sylvain.
Okay, so the first thing I would like to talk about is you want to launch tests, you want to test your data sets. How are you going to be able to do this? And the thing is, you have to interact at some point with BDF. Well, BDF offers an API that you can connect to, and it can be used either by a data zone dev, for which Loïc already has made a presentation on. And there's also a CLI, and I'm going to be talking more specifically about that CLI during this presentation. So the CLI comes with a bunch of commands to be used for development. We have, for instance, ls if you want to list all the datasets in the BDF catalog. You have show if you want to get some details about specific datasets. You have commands like format. We talked a few minutes ago about what can be offered by the CST, and format is one of the possibilities you can extract from that. We'll talk about the check command that will perform static analysis. And also there are some other commands. We're not going to be talking a lot about that. External, this is something that is needed in BDF, but it's not really the point of this presentation. Let's say, for instance, I want to check that my Git repository is fine. I just have to launch BDF check. And usually it's going to be telling me that everything is fine. Now, let's see what happens if I change something. And here, for instance, I have a very simple data set, which is I've checked hourly. And normally, what this data set does is a select of the partition hour as our copy. And as you can see here on the slide, I changed that with a select lol instead. And so as a result, BDF check will complain because lol is like an identifier. It doesn't know. So that's static analysis. Why do I talk about that? It's because if you want to interact with the server, BDF server, it has to know what's the current state of the code you have on your local machine. And to do that, the CLI will create a Git patch from what you edited, and it's going to be sending that to the server so that the server can have your local version of the code and can perform its test. There are other commands that can be used for operations, like describe backfill and backfill in case you want to regenerate corrupt data. Again, this is not the point of this presentation, but it's part of the CLI. And so these are the commands we are going to be interested in in the context of the continuous deployment, because this is about all the tests that we're going to be doing in production. So you can do a dry run, a diff, and an on-reg. And let's talk about, by the way, why do we want to validate our data sets in prod? Well, so as Rafael explained, you have static checks, and BDF can only validate what's really internal to the system. We cannot actually perform a SQL run on, let's say, Spark or Hive, or like do a run Python. Okay. And there's also a scalability issue. Why do we talk about scalability? Because, for instance, if I were to say that we would like to be testing our data sets in pre-prod, like it's a common thing we do at Criteo. I mean, before deploying an application in production, we usually deploy it in pre-production to see if everything goes right. But in the context of BDF and in the context of big data in general, we have issues there. We have a scalability issue because the pre-prod doesn't contain the same amount of data than the prod. And also those data that do not have the same statistical properties than in prod. And the results you might obtain from that, they might be completely different. As an example, let's say, for instance, that I have two very simple tables. I have people, and I would like to know what kind of breakfast did they get. And so people will point to breakfast, and you can see here that I have 7 people and 7 breakfasts, and everything looks fine. So that would be the data that I have in production. And so now let's say that because the pre-production cluster is not that big, I want to sample that data in order to reduce the size. And let's see what kind of statistical properties we have and what kind of issues we might have. So let's say I take only the 3 first rows of each table, I get that. And as you can see, either those rows, they have no starting points or no end point. So in the end, nobody is really related to any kind of breakfast. And if you run a data set that would like to extract some meaningful information from that, then it's helpless. So this is why we want to test in prod, but how do we do it without breaking anything? So the core idea of our dry runs is that we want to box things. We want that any data generated is going to live into the user space. When I say user space, it's really something like a directory whose owner is actually the user. And so it would generate tables, but those tables are temporary and they will live for a few days just for you to get the time to test them. Let's see how to do that. So imagine that I want to dry run some modifications I've been doing on iCheck already, the very simple data set we talked about earlier. First thing I would like to do probably is to do a BDF show because I want to know what's the list of partitions that can be dry run. So I do that. And then I do a BDF dry run, and the parameters are simply the data set and the partition. And what the CLI will print is the name of the temporary table that is going to be generated, and also a URL, like a link that is going to be opened automatically in your browser. And that will show you the execution logs for that dry run. So let's talk about that. So those are the very last lines of those execution logs. And what's interesting here to see is, so first of all, I have the name of the temporary table that is repeated there. It's not only on your CLI, but also in the logs. You can see just below a U-link and a very simple query so that you can query on U that temporary table that has been generated. And this query is just about displaying the first 10 rows of the table. And at the very end of the execution logs, because this specific execution is actually a Hive job, will tell you how many mappers have been used. Obviously, this is a very simple example, so only one mapper was used and no reducers. So we also indicate that. And we give you also the memory seconds and vCore seconds for that execution, so that you can get like a rough idea of how computationally expensive it was. Now let's talk about a diff, because you've generated a temporary table that is the result of your last modifications, but probably you want to compare that to the old version of the table, right? You want to know whether or not you broke anything. And so the way to do this is actually to do a diff. And a diff is nothing more than just joining an old partition before your change and the result of the new change. And you join that by specifying on which columns it should be joined. So here I have a configuration for a given data set that is going to be doing a join on arbitrage ID and impression ID. And then you call BDF-diff. So you specify the configuration file we just talked about, and you specify the left and the right tables, the ones that you want to compare. And obviously, because you do a comparison of a specific partition, you specify the left partition for the left table and the right partition for the right table. And so that would be the result of the execution of a diff. So a diff will produce a result which is both a JSON result in case you want to process it, but it will also generate an HTML file, which is kind of useful for the user. What can we see on this page? So we see that we have a lot of differences between the two tables, like something like 5,700. What is that more specifically? So we can see that we have the list of the fields here, and we can see that there are some fields that are only on the right tables. You can see them here, and if you click on them, you will get an actual display of those values in the JSON format. Also, we can see that not only you generated new stuff on the right table, but also there's been some changes here, and that probably means that either you corrected something on the old version of the table, or you broke something. So that's interesting to see. And this is reported as the little red point right here. On this page, if you get further down, you will see something that is also interesting. And it is actually what is accountable for the most part of the changes we've seen on the top of the page. So here, there's been many changes being done on a bunch of fields, because the type was changed from big int to int, actually. So if it's fine for you, then go for it. But if that was not intended, you're probably glad to see that, just so that you know you do not push that to prod. And now, what's a non-regression? Well, non-regression is just a way to launch a dry run followed by a diff. So the command is just here, BDF non-reg, you specify the data set, specify the partition, and you tell it from which on Git you would like to compare it to. And usually you want to compare your version of the data set to the master version of the Git repository. So now to wrap things up, BDF is a platform, and it's praised by its users because it offers a very good time to market, and it also a successful usage of continuous deployments, and that leverages static analysis for high return on complex issues, trustworthy and easy to launch tests, as Raphael advertised just before I started. So that's it.